Welcome to Study Loop.
Problem 7.8. The maximum energy that a bone can absorb without breaking depends on characteristics such as its cross-sectional area and density, so basically elasticity. So basically, if you have larger bones that can resist force better, they will be able to absorb energy better, so that when you fall or apply force to it, they won't break. And so they've measured that this is experimentally measured to be about 200 joules for that cross section. And so we're asked from approximately what maximum height could this person jump and land rigidly upright on both feet without breaking their legs. Okay, so essentially what this means is we have to equate the energy that we're given for the amount of breaking our legs to a certain height for when that person, lands from that certain height that they break their legs. So we have to equate 260 joules is equal to the potential of gravity. And that's just going to be our simple expression for mg, and then the change in height. So I'll write y2 minus y1. Okay, and from here, we're just going to have that change in height be one variable. It doesn't matter where we set the potential to be 0. And then we just put in what our mass and gravity is. So then when we write is equal to 60 kilograms times 9.81 meters per second squared. Y2 minus y1. We're just going to then divide both sides by the 60 kilograms and 9.81 meters per second. So there's just math, but then we get y2 minus y1 is equal to 0.34 meters. 0.34 meters, if you want British units, that's basically a foot. And so the question B basically says, you're probably surprised by this answer. You probably jumped down from a ledge that's more than a foot before. So yeah, you would be surprised. So basically, why is this the case? Part B asks, what else absorbs the energy when people jump from greater heights? Well, as we said before, this person is landing rigidly upright on both feet. So that means that if we have a person with their legs, this is their hip, and they jump and they fall down. They have knee here, they have legs there, and if I can draw feet that are very small, they're landing straight with their legs like that. But that's not how we usually land, right? Usually how you need to land in order to survive, your legs surviving that fall from at least a foot, you're going to have to land with your legs at some angle, right? So instead, what you have is that your joints and your muscles take up a lot of the burden, and you're also allowing your legs to compress a little bit in height as they go in this transition from only slightly bent to more bent. So that's why you have, when people fall into great heights, they may drop down so their hips are almost on the ground, or they may even do a roll. So that leads us into part C, why are older people much more prone than younger ones to bone fractures from simple falls? Well, in general, old people, their leg bones get less elastic, they can get more porous, and therefore they have less strength overall. But also their muscles are weaker, their joints are weaker, they may have slower reaction times, so that they don't really do well when they land. They don't catch themselves. They don't catch themselves well. So basically, C is that old people are weak. And that's essentially the answer to